Hello, my name is Tyler Crown, and today I'm going to be discussing radar and stealth technology and its impact on electromagnetism. So getting started, although radar is a relatively well-known field, it's definitely important to understand the foundations. Radar stands for radio detection and ranging, and this is because of its one antenna that doubles as both a transmitter and a receiver for microwaves. Radar was invented in 1935 by Robert Alexander Watson Watt. Primarily, this was for pilots to detect incoming storms. However, it did double as a great tool in World War II for the British. The picture of it is below. This is the first radar that was pretty much invented. So in terms of 303, we can see right off the bat that the electromagnetic spectrum and traveling wave properties are two very important concepts that should be known. If you understand how a microwave travels in free space, it's probably best for understanding how radar works. Thinking about it abstractly, though, I can see how transmission line theory can also be involved. For example, when you're given a reflection coefficient and a load impedance in transmission line theory, it's very easy to find the characteristic impedance. This is similar to how when you're given information about a radar itself and the wave that it sends out, you can find information potentially out about the object that you are looking for. So how does radar work? So radars transmit a focused pulse of microwave energy at an object. So part of this beam bounces back and gives back information about the object. For example, a large object would send back a high energy signal, and something that is either getting close or further would have changes in phase. Radar also times how long it takes for a wave to return to the receiver, and it tells how far an object is based on that. So a current radar that is used in society and is very well trusted for making decisions is the Doppler radar. So how the Doppler radar works, which we can see in picture 4, is that it sends a microwave pulse towards a storm and waits for a response back. And these microwaves bounce off individual water particles. And the resultant particle, for example, if the wave coming off of it increases its phase, we can tell that the storm is getting closer. And the radar scans about 7 seconds for every hour or so, so there's not much interference that we have to deal with, which is very convenient. So similar to how radar was used in World War II by the British, the technology has grown very popular for most armies around the globe. There are two types of radar that the U.S. Army uses. One is known as detection radar, the other is known as fire control radar. We're going to be discussing detection radar as it pertains more to stealth technology. So the radar that is used by the U.S. Army can bend the horizon and travel over 1,000 miles. While implementing this, though, researchers thought of counteracting this technology because they assumed that it would eventually be used against them. So they thought of something called stealth technology. So to briefly explain, a stealth aircraft is made up of completely flat surfaces and very sharp edges. When a radar hits a stealth plane, the waves reflect away at an angle, as you can see in picture 7, so the waves never make it back to the radar. Another way that stealth aircraft work are by absorbing the radar waves. So for example, the Lockheed Martin F-117A that we can see here, it absorbs the radar waves, so it appears to the radar similarly to a bird, so it just gets unregistered. So if we look a little more into stealth aircraft and the things that are done to prevent radar, we can see two U.S. ones in pictures 8 and 9 that we'll focus on. Number 10 is the Chengdu J-20, which was from China, but it's very similar to the ones that the U.S. had used to use. The B-2 is a very popular one that focuses on scattering the waves, and the F-35, shown in picture 9, focuses on absorbing the waves. So these are two approaches taken, and they're both used today still. So a lot of technology is being implemented to counteract this radar technology in the form of stealth, but it also primarily only happens in the Army sector of things. So radar and stealth summarized, radar has been around since 1935, and its significance in World War II proved to be a valuable tool for more than weather detection. Whether radar is a Doppler radar or an Army detection radar, the same concept is applied. Stealth technology does not emphasize blending into the environment. Instead, it emphasizes manipulating the properties of radar. And radar would not exist if it were not for the understanding of electromagnetic principles like wave propagation and the electromagnetic spectrum. Thank you.